All right, algebra kiddos, unit 4, lesson 2. This is a really important concept here of these linear equations. This is like the meat and potatoes of algebra. So, linear equations, you can see that the word linear has the word line right in it, which, if you could believe it or not, means that a linear equation will look like a line when it is graphed. So linear equations, first thing we're starting off, when graphed, they will look like a line. And the reason I'm not saying a straight line is because all lines are straight. If it's not straight, then it's not a line. All lines are straight. Boom. Okay, so this first part of this lesson is looking at how to determine if an equation is linear just by looking at it. Obviously, we don't know how to graph all of these things yet. Maybe you remember how to do some of them, but chances are you don't, which means there's got to be a way we can determine if these equations are linear or not just by looking at them. And there is. So how to tell if an equation is linear? An equation is linear if there are no exponents other than 1 or 0. So if there are no exponents other than 1 or 0, and if there are no weird groupings. So two main things that you want to focus on: no exponents other than 1 or 0, and no weird groupings. No exponents, no weird groupings. So we'll take a look at this in action in our example here, which so nicely corresponds with your first problem on your practice sheets there. Okay, so example 1. Which of the following equations are linear? Okay, so remember, we're looking for if there are no exponents other than 1 or 0 and no weird groupings. So looking at choice A, there are no exponents other than 1 or 0, and there are no weird groupings there at all. So that leads me to believe that choice A is linear. B, again, no exponents, no weird groupings, so B must be linear as well. C, no exponents, no weird groupings, also linear. D, I do have some exponents going on in D, so D is not linear because of the exponent. E, also same situation, not linear because of those exponents. F, D equals RT, no exponents, no weird groupings, so that is linear. G, x equals 7. This is a special equation that we'll look at in a couple of lessons. No weird exponents, no exponents other than 1 or 0. Remember that 7 does have a 1 on it, but that doesn't do anything. And no weird groupings, so G must be linear. H, remember those are our absolute value bars. And those are considered a weird grouping. That does count as a weird grouping, which means that that would not be linear. And last but not least, y equals 5. No exponents, no weird groupings. So 1, 2, 3, 4, 5, 6 of them are linear out of the 9.